Hello and welcome to our curriculum night. I know this is very unusual for all of us for the school year of 2021. My name is Mrs. Rodriguez and I am teaching Integrated Math 3 this year. My name is Estella Rodriguez and I can be reached at erodriguez@lths.org, or I also would like phone calls, and my extension is 8470. A little bit about me: I've been teaching for 21 years, but past 21 years is completely different than what's going to happen this year. I am a wife and a mother of 4 children, so my 4 kids do keep me busy. So I enjoy spending time with my family, and I enjoy walking, working out, and love to scrapbook with friends and family. The course for Integrated Math 3 is a 3rd-year course for graduation requirements for the college and career prep. We also prepare students to take a 4th-year course if that is what you choose to do. It could be CAT, probability, discrete, STEM. We have many 4-year level math courses. For the course itself, for Math 3, we do have topics ranging from polynomial functions, rational functions, inverse functions, exponential, logarithmic functions. And, that could be foreign to some of you, but it is the 3rd-year course that we offer here at LTHS. The 4th bullet is just explaining the textbook that we have online that we will be using. It's our new course that we got this year. Realize, Pearson, and students have been already using that online. So if students are struggling and if they need assistance, from the 1 to 4, 5 to 7 class periods, after that, there are so many opportunities that they can meet with any teacher, as long as we know that they're coming on intervention time, remote learning time. We do have kitchen tables setting up from 3 to 4. That is obviously after school hours. And then if a student wants to meet with me, definitely, they can communicate with me through email. They can give me a call. They can definitely set something up as a one-on-one. And then last, when we are in front of the computer, one-on-one, or as a group, hopefully they are getting used to being, on time with their Google Meet, definitely with their camera on, mic muted, and then being prepared and productive. Of course, doing their assignments in class, outside of class, trying to do classroom discussions more. I know it's kind of a weird situation being on a computer screen, but hopefully we can have those discussions more and more as we get through this. And then every day I've been reminding students, make sure you have your workbook, make sure you have your pencil, pen, calculator. Definitely need those supplies to start the school day. Being respectful. I've had no issues, knock on wood. The etiquette, which is called now netiquette, of having that respectfulness when you are in the classroom on the computer. And then, of course, sharing some responsibility, visiting the Google Classroom, submitting assignments on time, and then, of course, seeing the calendar weekly for the class. If you have any questions of the class, you can please reach me. Again, erodriguez@lths.org, or by my extension 8470. Thank you. Hi class, I am doing this video for so many students that missed on that Wednesday for the practice SAT. So I'm going to finish the notes for section 2.4. So the last example that we looked at was synthetic division. And again, if you have any questions on how we did this, make sure you ask me during class, come into Compass, so forth, okay? So we're going to continue with our examples. So example 3, we have to know the remainder theorem, and I'm writing it right here off to the side. So then that way we have it for reference. And this theorem is going to help us with using synthetic division. It says if a polynomial, and we're going to say p of x, is divided by the factor x minus a, then the remainder is equal to p of a. So I'm going to explain what this theorem is saying. It is saying that we're going to take this function, and it's two things. We can solve by using substitution, and let's put in -2 into our function. So I'm going to substitute in this equation, I'm going to substitute -2 wherever I see x. And we're going to find the answer, but not just yet. Okay, so we're just saying, okay, equals, and we'll put a question mark there. Okay, now in order to do this, you have to follow order of operations. You're going to have to probably pull out your calculator and figure out what this answer is, where x equals -2. But this theorem is telling us if you use synthetic division with the x value, which is again -2, and again setting up synthetic division, whatever the remainder is, which would be in this last spot right here, whatever the remainder is, it is equal to the final answer, to the function evaluate at -2. Well, if I see this and if I do synthetic division, okay, as I'm doing it here, add, multiply with the -2, add, multiply, I can get this answer a lot faster than doing my evaluating. So the answer is 5. So that means, instead of removing my question mark here, I'm going to write 5. Okay, so that is the same thing. So that's what the remainder theorem is saying. Okay, and we're going to use that in the next example. Using the remainder theorem, evaluate the polynomials. So this technology company has this revenue function, and they want to estimate the revenue in year 5. So after 5 years, what is their profit? So we're going to do 2 ways. The first way was evaluate the function by putting in 5 in for x. So we're saying 12, 5. I'm putting it in for x. And there's a lot of places, more than one, and we have to come up with an answer, right? So again, question mark. Following order of operations, make sure you enter that into your calculator carefully. But the remainder theorem says there's an easier way to do this. We're going to put that 5 in as our divisor, and we are going to put in set up synthetic division, and that's a lot easier. So we're going to drop the -1. Remember, always multiply with this 5. And we're going to multiply -1, and that value goes here. Add, going down, multiply, we get 35. This is 41. Again, adding, multiplying, that's 205. Add, and that's 285. So this is our remainder. So that means that if we were to evaluate this equation for x equals 5, we would get 285. So what does this 285 mean? Well, it means that the revenue, and it did say in thousands, the answer is $285,000. That's good revenue for a company, especially in 5 years. Okay. So if I had to choose personally, I would use synthetic division because it's a lot faster and all you're doing is multiplying, adding, and you don't have to worry about going to a calculator, using the order of operations, make sure you're keying that in. It's just a lot easier. So let's use that remainder theorem, okay? All right, the other theorem is called the factor theorem. And the factor theorem is saying if the expression, we're going to write x minus a is a factor of the polynomial if and only if the remainder is 0. You can also say the value of a, when you do that substitution, it equals 0. And that's, again, the remainder, okay? So let me go back to, because I did this in class, let's look at the very first page, and I'll circle this. Remember this question right here with Benson? He tried to divide 6 into 83. It's not a factor. And hopefully you can see why, because you get a remainder of 5. So I had students say it doesn't go in evenly. There's 5 left over, and that's correct. Versus here, 6 can go into 192 evenly, and it's a factor. Why? Because you get a remainder of 0. There's nothing left. So 192 divided by 6 comes out to equal 32, right? 0 is a remainder. So depending on what you're going to see, is it a factor? That's because it has a remainder. If it doesn't have a remainder, then it's a factor. And that's what you're going to do with polynomials. And that's the last example. If the expression is a factor, if and only if, that is a very important statement right there. The remainder is 0. If it's not 0, it's not a factor, right? Okay, so let's look at the question here. P of x, that's my polynomial. I am asking, is x minus 4 a factor? That's my binomial. So I'm going to put, and remember, this is a factor. And when you set up synthetic division, it is the opposite. That is your solution. So setting up the synthetic division, and again, bring down the 1, again, multiplying across, add, multiply, add, and multiply. I'm always multiplying by that 4. And this is the remainder. It's 0. So that x minus 4 is a factor to our polynomial. Okay. All right, let's do the next one, and this wraps up the notes here. So if you want to pause this, if you want to give it a try, again, x plus 5 is the factor. We want to know, is a remainder of 0 going to be, or is it going to be something else, right? So let's put in our numbers here. We get 2, 9, -2, 6, and -40. So let's see here. Bring down the 2, multiply, -10, add, down, 5, 3, -15, -9, 45, and I get a remainder. So guess what? This is not a factor because we got a remainder of 5. Is not a factor. So that is the end of the notes. If you have any questions, maybe watch this again, but, any questions, make sure that you reach out to me. Okay? All right. Have a good one.